the heat of combustion of neopentane is 3,250 kilojoules per mole. That of pentane is 3,269 kilojoules per mole. Which statement best describes the relative stability of these two compounds? Okay, so we got some answer options here. Let's first make sure we know about heat of combustion. Okay, so, first we should think about this neo. Okay, so I don't remember being introduced to the neo prefix in organic, but I'll show you neopentane. Right. Okay, so here is neopentane. Right, you don't really need to be able to draw the structure in order to solve this problem, but you do need to know that neopentane and pentane are not the same thing. So a neo is the prefix for a straight line carbon chain attached to two carbons. I think it has to be two methyl groups, I believe. But anyway, pentane, right, we know pentane. So let's review heat of combustion. Okay, so heat of combustion, right, we burn this guy, okay, and we turn it into H2O plus CO2, right? And so the same exact thing would happen if we took, hopefully you can see this all the way down here on the video, pentane, and we burned it with oxygen from air, right? We just get water and carbon dioxide. So the key is both of these two products are exactly the same. So they have the exact same stability, right? So what we care about for heat of combustion is the amount of delta H, change in H, the amount of heat that's released, which will be the difference in change in H from products to reactants. Well, actually I should put this way, right? Because it'll be this guy minus this guy, yeah. Okay, so delta H with increasing going up. This is the reaction coordinate down here. So as we go from, let's think, reactants to products, right? And so both of these guys have the same stability of the product. Okay? So we determine delta H by change in H products minus change in H of reactants. So it'll be the difference from here to here. Okay? So since the stability of the product is the same for both pentane and neopentane, what will determine which heat of combustion is greater will be the stability of the reactant, right? Okay, so basically the guy that is more unstable will be up higher here, and so we'll have a greater difference from product to reactant, will release more heat, we'll have a higher number, right? So neopentane must be more stable than pentane by 19 kilojoules per mole, right? Because, let's see, this guy is 19 lower kilojoules per mole in the heat of combustion, right? And we're just taking delta H products minus delta H reactants, right? And the product is the same. So let's see, we could actually, let me think, should I do this real quick? Let me see, if delta H equals delta H reactants minus delta H products, right? And so let's say this is for neo, and this is for regular pentane right here. Delta H equals delta H reactants minus delta H product. So I'm just figuring this out by myself right now. But so these two guys are equal, right? These are exactly the same. So what we could do is, if we subtracted these two equations, right, we'd get, what would we get if we took this guy minus this equation, right? We'd get, let me try to squeeze this in, right? Answer is going to be C, right? So you see it there. I'm just messing around at this point. So let's see, if we did this equation minus this, we'd have delta H neo minus delta H regular pentane will be delta H. Well, so this is for the reaction. So call this 1. We'll call pentane 2. Right, so let's do delta H 1 minus 2. So delta H, what is the reactant here? It's neopentane minus delta H pentane, right? And this becomes minus delta H H2O CO2 minus negative, so plus delta H of H2O CO2. That cancels out, right? So you just have the difference in this number and this number. The actual heat of combustion is equal to the difference in the heat of the reactants, right? So here, yeah, you can see this exactly shows how the stability of the reactants indicates the difference between these guys, right? So I mean, we could even plug in our numbers, right? 3250 for reaction 1 minus 3269 equals, let's just say, I mean, neopentane stability minus pentane stability, right? And so this becomes negative 19, right, equals the neo stability minus the pentane stability, right? So neopentane, right, we want lower number is more stable. So neopentane is more stable by 19 kilojoules per mole, as is answer C. So I like to use math. That makes it more reasonable to me. But hopefully the worded explanation in the beginning also helped you out.